Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields, and today's lecture topic is Electrostatic Energy. On completion, the students will be able to define what electrostatic energy is, understand the concept of static charge, and derive the equation for electrostatic energy. Electrostatic energy. The term electrostatics refer to electromagnetic phenomena which occur when there are no moving electrical charges on or within a given material. When electrostatic energy is built up on a given material, it is referred to as static charge. The amount of static charge that an object can hold depends on the physical properties of the material that is used for constructing it. In electricity, the principle of conservation of energy will be useful for discovering a number of interesting things. The law of energy of interaction in electrostatics is very simple. Let's consider two charges Q1 and Q2 that are separated by a distance R12. There is some energy in the system because a certain amount of work is required to bring these charges together. We have already calculated that work done in bringing the two charges together from a large distance is given as Q1 Q2 by 4 pi epsilon naught R12, where Q1 and Q2 are the two charges and R12 is the distance of separation between them. As per the principle of superposition, if we have many charges present, the total force on any charge is the sum of the forces of each other from others. The total energy of a system of number of charges is the sum of terms due to the mutual interaction of each pair of charges. If Q1 and Q2 are any two charges and R12 is the distance between them, in general we can consider the energy of such a pair of charges as Qij divided by 4 pi epsilon naught Rij. The total electrostatic energy U is the sum of energies of all possible such pair of charges, and it is represented as U, which is equal to summing up of all pairs of charges Qj divided by 4 pi epsilon naught Rij. If we have a distribution of charge specified by a charge density ρ, then the summation equation can also be replaced by an integration. The diagram given here reveals that the electrostatic energy of a system of particles is the sum of the electrostatic energy of each pair. Here two aspects of this energy are noted. One is that the application of the concept of energy to electrostatic problems, and the other is the evaluation of the energy in different ways. Sometimes it is easier to compute the work done for some special case than to evaluate the sum in the previous equation or the corresponding integral. As an example, we shall calculate the energy required to assemble a sphere of charge with a uniform charge density. The energy is the work done in gathering the charges together from infinity. The energy of a uniform sphere of charge can be computed by imagining that it is assembled from successive spherical shells. Consider that we assemble the sphere by building up a succession of thin spherical layers of infinitesimal thickness. At each stage of the process, we gather a small amount of charge and put it in a thin layer from R to R plus dr. The process is continued until we arrive at the final radius A, as mentioned in this diagram. If Qr is the charge of the sphere when it has been built up to the radius r, the work done in bringing up this charge is given as du is equal to Qr dq divided by 4 pi epsilon naught r. If the density of the charge in the sphere is ρ, then the equation Qr can be replaced as Qr is equal to ρ 4 pi by 3 pi r cube, and the charge dq can be written as dq is equal to 4 pi r square rho dr. Substituting these values in the work done equation du, we are getting the equation as du is equal to 4 pi rho square r power 4 dr divided by 3 epsilon naught, and we can obtain the total energy required to assemble the sphere by integrating the value with r equal to 0 to r equal to a, and we get the value of total energy U as 4 pi rho square a power 5 divided by 15 epsilon naught. The above equation can also be given in terms of the total charge Q, and here the equation is written in terms of Q, and the total energy U is equal to 3 by 5 Q square divided by 4 pi epsilon naught A. So here from this equation we can obtain the relation between the total energy and the total charge. The energy is proportional to the square of the total charge and is inversely proportional to the radius A. Quiz questions on electrostatic energy. What do you mean by electrostatic energy? Define static charge. Determine the energy required to assemble a sphere of charge with a uniform charge density. Thank you.